Alright guys, today we're talking about scale factors. Okay, and just kind of changing formulas. So, if we were talking about like changing one equation to another equation, the volume, let's say that. Okay, so let's say I have a cone. Okay, and my radius is 5 and my height is 8. And these are meters. So the first thing we want to do is figure out the volume of our cone. Okay? So the volume is pi r squared times height, divided by 3. So I'm just going to type this in, and I'm going to keep it in radians so that you can see better. So pi r squared, I guess I should put, I think it'll do it, that's fine. And then over 3. Okay, so we have 200 pi cubed. Alright, so now I want to double these items. So I want the volume to double, okay? So that will be my scale factor by 2. So we're going to double. And we're just going to kind of look and see what happens. So that means that now my radius is 10 meters and, actually wait. Yeah, this is fine. Okay, so we're going to double my measurements first. 10 meters and 16 meters, and we're going to see. So now we have V equals pi 10 squared times 16 over 3. Okay, so we're going to type it in the exact same way. Times 100 times 16 over 3. That's not a 3. There we are. So we get 1600 pi over 3. So really right now all that's really changing is my 200 and my 1600, right? Because it's divided by 3. So we're going to figure out the relationship between the two of those. To go from 1600 to 200, 1600 divided by 200, that's 8 times. So even though I just doubled the lengths, I changed my volumes to be 8 times more from my original to my new. Okay, so now let's just double this volume and see what we get, okay? So we are going to do 2 times 200 pi over 3 and see what we have. So 400 pi. Alright. So I want to go from this to this. Or this to this. So there's a big difference, right? I can't just double numbers and expect my volume to double because it's not going to happen. Okay, so this is times 2 and this is times 8. Okay, so here's the thing that is happening. Okay, hold on. Sorry. Okay, so what's really happening is this scale factor of double is times 2, right? So if I'm doubling the radius and I'm doubling the height, to get 8, remember volume is a cubed unit, right? So if I wanted to double my radius and I wanted to double my height and figure out what my volume is quicker, all I would have to do would be to triple this guy, okay? Or to put it to the 3rd power, because my volume is cubed, so there's 3 measurements. There's 2 radiuses and a height, because I have my radius squared and a height. So that's where you get your cube from for your volume. So really what we're doing, if we wanted to shortcut to here, we would take whatever measurement we have. So if whatever our scale factor is, it could be a fraction or a whole number. We cube it because volume is 3-dimensional, and then we can get the new volume that we would have. So 2 cubed is 8, right? So let's just if I multiplied this guy, our original volume, 200 over 3 pi times 8, I would get my new volume as a shortcut. But I couldn't double my volume. So this is more than double my volume. This is double measurements. And this is double volume. So there's a really big difference here. So if you just multiply the original volume that you have by your new scale factor cubed, then you are stretching your shape. You are not doubling or quadrupling your volume. So let me show you on another example. So let's say that we have, let's go with a cylinder. Okay, and I'm going to tell you that my radius of my cylinder is 1.5 meters, and the height of my cylinder is, I don't know, 5 meters. Okay, now let's say that I am making a similar figure, okay? So my scale, I need to get this guy into a bigger form. So to have a similar figure, I have to stretch my radius and my height, right? I'm not just doubling my volume or tripling or whatever. And this time we're going to quadruple. So we're going to scale up by 4. Okay, and then I'll show you where we decrease. So in order to scale this up by 4, the first thing we could do, so you have 2 options. The quickest, well, it kind of depends on what you're beginning. I want to do the regular method because it will apply to both. So the first thing we're going to do is figure out the volume of this shape. So the volume of a cylinder is pi r squared times height. Okay, so you could have just multiplied these by 4 and then you would have the answer. But since we're going to use this volume again, we might as well just figure out the volume of the original. So pi times 1.5 times 1.5 times 5 is 35.3. Okay, so the volume of this shape is 35.3. Well, since I want it to be 4 times larger, and volume is cubed, in our calculator we do 4 cubed. So 4 cubed is 64. So we will multiply 64 times 35.3, and that'll give us our new volume. So times 35.3 is 2259.2. Oh, I guess we should put units. Okay. Now, if you don't believe me, let's do it. So 1.5 times 4 is 6, and that's our radius. And then 5 times 4 is 20, is our height. So in the calculator, it would be pi times 6 times 6 times 20, which is, a little off. It's because we rounded, but it's right about there, 2259, 2261, okay? So we did a shortcut, which is pretty fancy. And you can even go smaller. So like if you're like, oh no, I need to make this guy 2/3 the size of its original, okay? So for 2/3 for fractions, you still do the same thing. You have to cube them because volume is cubed. So you'd have to figure out what that is first. So 2 over 3 cubed is 8/27. And we could get decimals, but as you see, decimals lead to not pretty numbers. So we now multiply 8/27 by 35.3. So 8/27 times 35.3 is 10.5. So this volume would be 10.5 meters. Okay, so you can quickly use the original volume, which we got here for this shape, to scale your shape larger or smaller, and these are all proportional or similar figures. Okay, because they're both scaled, so I scaled my radius and I scaled my height. All right, so that is one way to use these scale factors. Then, okay, so on your homework for today, The ratio of surface area of the smaller prism to the ratio of surface... Okay, so I've included the surface area ratio for you. Same thing with number 2. I've included the area formula for a trapezoid for you. So B1 is your base, and B2 is your other base, and then height. So the area of this trapezoid, we'll call him 1. So area of 1 is 1/2 base 1, 10, times base 2, 2, and then times your height, which has to be this height, the actual height, not your slant heights, so that's 5. And the same thing with this is shape 2, so it's area of shape 2, and then it's 1/2 your base 1, which is 6, times your base 2, which is 1.2, times your height, which is 3, and then you'll be able to compare the two. Okay, so there's a little insight into that one, but we are going to be looking at this guy. Okay, what is the ratio of the surface area of the smaller prism to the surface area of the larger prism? So surface area, you have to calculate all these outside rectangles. Since they each have a pair, that's why the formula is 2. And then it's length times width. So it's using the different measurements. So this guy is 3, this guy is 6, and then this is 4.5. Anyways, all right. So just give it a letter. Length, width, height, and then it'll be easier. So this will be shape 1 and shape 2. So the surface area of our first shape, oh, we should do that again. I liked that notation. Of shape 1 is 2 times our length times our width, and 2 times our length times our height, and 2 times our width times our height. Okay, and then I'm going to throw this whole thing into the calculator. 2, there we go. Oh, it's so cute. Okay, 2 times 4.5 times 6, and 2 times 4.5 times 3, and 2 times 6 times 3 is 117. So this one is 117. And then we do it again. Let's do length, width, height, it doesn't matter. 2 times length times width, and 2 times length times height, and 2 times width times height. Okay, so we've got 2 times 6 times 8, and 2 times 6 times 4, and 2 times 8 times 4. 208. Okay, so the ratio, we're going to put the first one first. So 117 to 208. And basically this guy's like a fraction, so you could put him in our boxy fractiony button and put 117 over 208, but he doesn't, oh, he does reduce. Look at that. So it's really 9 to 16. That is a ratio from the littler rectangle to the bigger rectangle. And again, it doesn't matter what order you put these guys in, but we're going to go left to right. So on the trapezoids, go left to right. Okay, so what is the ratio of the volume of the smaller prism to the volume of the larger prism? So we have to calculate the volume of each. So remember, volume of 1 is just all of them multiplied together. So 4.5 times 6 times 3 is 81. And then the volume of the second one is 6 times 8 times 4, which is 192. Okay, so then it says the ratio, so we write 81 to 192. And then again, in our calculator, we're going to see if that reduces 81 to 192, and we get 27/64. So those are the ratios. Now the scale factor. So remember, the scale factor is you have to divide like things. So we're going to divide 4.5 by 6. 4.5 divided by 6 And again, I'm sticking with my littler divided by my bigger. So 4.5 over 6 is 0.75. And it should be the same thing with anything else. 6 over 8, 0.75. But that one will reduce a lot better, which it, oh heavens, 6 over 8 is 3/4. Showing you how you can get your fraction. And this guy. Okay, so that's how you do that. So scaled factor is dividing. I want the fraction, and ratios are writing the numbers next to each other with this cute little symbol. It means compared to. Okay. Let us see. Okay, what else did I want to talk to you about? Oh, let's do 9. You and your friends are both bringing cylindrical thermoses of water on a camping trip. Your thermos is twice as big as his in all dimensions. How much more water will your thermos carry than your friend's if your friend's thermostat has a diameter of 10 and a height of 18? So this is when we can use our cute little trick. And these are centimeters. Alright, so the first thing we're going to do is figure out the volume of your friend's. And then we're going to figure out it wants the dimensions of your thermos. Okay, so the first thing we need is the radius, which is 5. I keep saying the first thing, I'm really sorry. So then we have, it's twice as big as his in all dimensions. Well, that's super easy. If his diameter is 10, then your diameter is 20. And if his height is 18, then your height is 36. Wait, that's all they want? Okay, well, I guess our dimensions are our diameter of 20 centimeters and a height of 36 centimeters. That was uneventful. I wanted to do more. Okay. Well. Okay. I think you guys can do the rest. Another movie theater sells a small... Okay, let's look at 14. Another movie theater sells a small cone of popcorn for $2. A medium cone of popcorn is sold for $4 and comes in a similar container as the small, but the radius is twice the length of the small container. Which popcorn gives you more for your money? Explain your answer. Okay, so let's say that our height is 4 and our radius is 2, and that would be $2. So let's figure out the volume of that guy first. So we have 2 times 2 times pi times 2, no, times 4, that's our height, times 1/3, so 16.8. So 16.8 is the volume. And the medium cone of popcorn is sold for $4 and comes in a similar container as the small, but the radius is twice the length of the small container. So now our radius is 4. Well, if I doubled my radius here, and it's a similar container, then I also have to double my height. So this is now 8. So now we're going to figure out the volume of this guy. So we have 8 times 4 times 4 times pi times 1 divided by 3 is 134.0. Okay, so now I want to figure out how much we're paying per dollar for each of these. So I'm going to take 16.8 and divide it by 2, and I get 0.9. And then we're going to take 134.0 divided by 4, and we get 33.5. So we're paying $1 for 0.9 volume, of however much it is, or we're paying $1 for 0.33 volume. It seems like the radius that is twice the length is giving us way more volume for our money. Okay, let me know if you have any questions. Have a great day.